Goliath Tracked Mine is a perfect example of technology that was too far ahead of its time. Designed and produced in the Third Reich, this remotely controlled, unmanned ground vehicle featured armor plating, tank-like wheels and rollers, and the capacity to carry up to 100 kilograms of explosives. Once it breached enemy defenses, the explosives could be detonated at the touch of a button, ensuring that the piloting Panzer engineers remained out of harm's way. Today, unmanned vehicles, better known as drones or armored robots, are common in every conflict. However, in the 1940s, the concept was revolutionary. Had the Goliath succeeded, it might well have altered the course of World War II and perhaps even reshaped the nature of modern warfare for decades to come. But if an explosive World War II robot existed, why have you never heard of it, and why didn't it win the war for Germany? Was it that the technology was so far ahead of its time that engineers didn't know how to properly utilize it, or did Germany simply fail to grasp its potential and neglect to invest in what could have been a war-winning secret weapon? Allied troops would have been horrified to see a 2-foot-high miniature tank trundling across hostile territory toward them. At first, the soldiers might not have understood what they were witnessing, but it wouldn't have taken long for them to learn the hard way that this is what modern militaries now call a suicide robot, an unmanned ground vehicle designed to slip behind enemy lines, detonate, and inflict massive damage while keeping its operator safely remote. Although this functionality remained theoretical in the 1940s, since the Goliath was very much an experimental concept, the Wehrmacht believed they'd finally secured a unique advantage over the Allies. Had they invested more in the Goliath, it might indeed have played a pivotal role in securing a German victory. The Goliath Tracked Mine, also known as the Leichter Landestrager or Light Charge Carrier, was developed for the German military by Borgwood Automotive Company. The robot was intended to either target high-value Allied assets, such as tanks and structures, or serve as a first-wave spearhead against reinforced defensive positions. In 1944, the Americans captured several unused Goliaths and compiled a report for higher-ups that provided a thorough description of the robot and its various components. This report remains available today, offering a complete overview of what the Goliath was and how it operated. The report reads, "The hull is fabricated from 16-gauge mild steel and protected by sloping 9mm armor plates set at 48 and 50 degrees to the vertical. It's divided into 3 compartments. The rear compartment houses the cable and drum, the central compartment contains the power unit and control mechanism, and the front compartment holds the explosive charge. Steering is accomplished by braking the circuit on the side where a turn is desired, which releases a magnetic clutch and cuts power from the engine on that side of the vehicle. The suspension comprises 5 small bogie wheels on the bottom, 2 return rollers on top, and an idler wheel at the rear. Each bogie is independently sprung by coil springs. The chain-driven sprocket is located at the front of the vehicle. For operation, the engines are started by a hand crank, the clutches are engaged, and control is transferred to a control box via a cable." So, that rear-stored 3-strand cable was 650 meters long, enabling the robot to travel a considerable distance before detonating. The report also mentions that the engine was started by a hand crank, although this detail refers to the later 303 iteration, which was fitted with a 2-stroke petrol engine. The earlier version of the Goliath, the 302, used a pair of electric motors that were later replaced to save on production costs, a cost reduction strategy that we will return to later, given it has a major role in the Goliath's eventual failure. Now, you might have already concluded that the Goliath was well ahead of its time, but the surprising truth is that remotely controlled military units were not new, even during World War II. The origins of unmanned explosive carriers go back even further, having been initially developed during World War I. Although the World War I versions are not well documented, the first models mentioned include the Crocodile Schneider Torpedo Terrestre, or Land Torpedo Crocodile Schneider, and the Oberoge Bay Electric Torpedo. World War I is notorious for its trench warfare, a tactic that gave rise to the term no man's land to describe the hostile territory between occupied trenches. Early unmanned explosive carriers were designed to cross no man's land, deliver explosives, and disrupt enemy defenses, all without exposing soldiers who remained safely in their own trenches. These robots were admittedly primitive, reportedly unable to even turn, yet they saw use in actual combat conditions as early as June 1916. The effectiveness of these early machines was not well documented, likely because the debut of the first tanks on the battlefield made virtually everything else seem rather mundane by comparison. Years later, in 1918, Elmer Wickersham patented the Wickersham Land Torpedo, a design later borrowed by French inventor and vehicle designer Adolphe Cagrès in the 1930s. It was Cagrès's version that fell into German hands in 1940, prompting the Wehrmacht to order the Borgwood Company to develop a modernized variant. In this context, modernization meant creating a remote-controlled vehicle capable of turning left and right, as well as moving forward and in reverse. although the reverse function was later dropped after switching from an electric motor to a petrol engine. Given everything that we've discussed, the Goliath truly had the potential to be a war-altering technology. The next question then is why the hardware failed so miserably and why it has mostly been forgotten. The first clue lies in the Allied response to the captured Goliaths. Allied engineers received the captured Goliaths along with the earlier report and were ordered to study the technology, analyze its potential, and decide whether a similar design should be adopted for Allied armies. The unanimous conclusion was that the Goliath held no value for the war effort. In fact, most of the captured Goliaths were either used as entertainment for the troops or handed over to the United States Army Air Force to serve as aircraft tugs. Even in that role, however, the robots proved ineffective. They broke down a lot and required constant maintenance. And on the subject of their frequent breakdowns, a German document recovered with the units offers additional insight. The document states, care and treatment of Goliath in the field. 1. Practice driving is forbidden. 2. The Goliath must be stored in a place that is dry and safe from shell fragments. 3. Special care must be taken to keep the steering mechanism, relay system, and operator's control box dry. 4. From the operator's control box of the Goliath, the field cable is laid into a cable ditch 0.8 to 0.1 meters deep until it reaches the point where the cable is brought up and connected to the corresponding wires of the Goliath's cable. 5. The Goliath must be cleaned daily. As this document suggests, contrary to all expectations, the Goliath was a delicate piece of hardware. The cable connections and control box were prone to water damage, the engine experienced frequent breakdowns and required constant maintenance, and the exterior just wasn't particularly well armored. In addition, the Goliath had a maximum speed of only 6 kilometers an hour and would get stuck on even the most basic of terrain. The design, overall, was poorly suited for wartime conditions, making it surprising that the hardware was deployed at all. Most of these design flaws could have been fixed relatively easily. And that brings us to the next question. Why didn't the German army fully commit to refining the Goliath and developing a piece of military hardware that would give them an edge over the Allied forces? Now, the primary issue with the Goliath and similar remote control designs was cost. Keep in mind that each unit was intended to be single-use, so justifying further development or improvements was counterintuitive from the perspective of higher-ups. Instead of investing in enhancements that were sorely needed, the Wehrmacht prioritized reducing costs, which meant the Goliath became gradually worse rather than improving over time. The earliest version of the Goliath using the electric engine cost around 3,000 Reichsmarks, and although it's difficult to translate that into modern currency, one point of comparison is that an effective Stug 3 tank cost around 82,000 Reichsmarks. In the later years of the war, Germany was also grappling with a collapsing economy and severe resource shortages, so committing additional funds to an experimental design was far from a top priority. As a result, the single-use Goliaths were stripped down as much as possible, hastily assembled, and deployed in a condition that allowed them to function only for as long as was minimally necessary. Predictably, this meant that Goliaths quickly earned a reputation for failing to work more often than they did. The specialized panzer crews and combat engineers assigned to them ended up spending more time addressing hardware issues than actually using the vehicles in battle. Now, the issues were extensive, though one might have defended them if Goliaths had consistently proved to be a decisive factor in battle, scoring kills every time they were deployed. In reality, a Goliath rarely even reached its intended target, with most units simply abandoned on the battlefield. First and foremost, transporting Goliaths was an enormous challenge. Each unit weighed a hefty 430 kilos, requiring a chain of heavy transport vehicles to bring the hardware to the front lines. Moreover, once at the front, moving a single unit required multiple soldiers, whether to store it or relocate it to a potentially useful position. Placing a Goliath in the right location at the right time was a constant struggle of exhaustion and back-breaking manual labor. When the Goliath was finally called into battle, the situation hardly improved. The American report noted that the Goliath had enough power to operate on almost any terrain, and this was true in theory, as the engine was indeed powerful. However, the robot's extremely low top speed of 6 kilometers an hour, coupled with an insufficient ground clearance of only 4.5 inches, significantly hampered its effectiveness. Regarding speed, Allied troops could see and hear a Goliath approaching well in advance. This advance warning gave them ample time to either target the robot with gunfire or simply retreat at a leisurely pace. Furthermore, taking evasive action might not have been necessary at all, given how frequently the Goliath just became stuck in the terrain. Its poor ground clearance left the heavy machine vulnerable to obstacles ranging from bomb craters to loose rubble. In such situations, engineers typically choose to abandon a stuck Goliath rather than risk the dangers involved in a recovery attempt. Piloting engineers were instructed to scout the terrain carefully before deployment and to cover the Goliath's approach with gunfire or smoke grenades. But doing so meant that the operators would not remain hidden for long, which leads us to our next point. The specialized panzer operators were easy targets. Keep in mind that a clear line of sight was necessary to steer the robot accurately. Although a cable length of 650 meters was useful in theory, it also meant that engineers were likely nearby with a direct cable connection to their location. It was not uncommon for the cable to become caught on terrain, wrenching the wires from their connections, or for artillery fire to sever the cable long before the explosives reached their intended target. If all else failed, and Allied soldiers did decide to destroy Goliath, they could do so with ease. The original model, powered by an electric motor, was protected by just 6mm of armor, later upgraded to 10mm after switching to a petrol engine. Even then, only the front of the Goliath was shielded, leaving the sides and wheels completely exposed. A simple burst of small arms fire was enough to destroy the wheels and disable the robot, effectively turning a handful of bullets into a direct 3,000 Reichsmarks loss. Of course, Wehrmacht engineers attempted to maximize the potential of their Goliaths. They determined that the best strategy was to deploy the robots in advance, conceal it, and wait for enemy troops to arrive. Once an enemy approach was detected, the Goliath could be guided out of hiding, piloted toward a target, and detonated at the precise moment. This tactic was even employed on the beaches of Normandy during D-Day, with reports indicating that several Goliaths were concealed on the beach in anticipation of Allied landings. A sound strategy, but since the Allies thoroughly bombarded the beach before attempting to land, every Goliath was either destroyed or had its cable severed. As a result, the Goliath proved completely ineffective, and it's no wonder that the unit is virtually never mentioned today. It's reported that 7,564 Goliaths were produced, and given how rarely they were actually detonated, many are now on display in a long list of museums. The experimental project was, naturally, seen as a huge disappointment, and there were no serious attempts to develop war-ready remote-control robots or drones until years after World War II. There was, however, the remote-controlled Soviet tank known as the Teletank, which we will absolutely get into in a moment. First, though, let's appreciate that although we've detailed the Goliath as a failure, the unit wasn't entirely without sporadic success. In 1944, the Goliath was promoted as a frontline tactic, and Allied troops reported encountering the hardware at the Battle of Anzio in Italy, during the Warsaw Uprising, and during the landings in southern France in the Maritime Alps. In the last instance, the 509th Parachute Infantry Battalion witnessed a vehicle being destroyed by a Goliath. According to reports, when a Goliath managed to reach its target and detonate successfully, the resulting damage was devastating. It is also mentioned that Goliaths proved useful in the summer of 1943 near Kursk, though perhaps not in the most cost-effective manner. To navigate extensive Soviet minefields, Goliaths were deliberately employed to trigger mines and clear a path. The tactic ultimately allowed Elephant/Ferdinand tank destroyers to pass through unharmed. And look, while our focus has been on Germany today, there are scattered reports of remote-controlled technology experiments by other nations. Notably, the British experimented with a mobile landmine at roughly the same time that Germany introduced its version into battle. The mobile landmine was designed by the electrical engineering company Metropolitan Vickers in 1940, with a prototype successfully tested in August 1941. Following this, an order was placed for 50 mobile landmines to be produced and tested, along with an analysis of their potential on the battlefield. In 1942, the Commander-in-Chief of Home Forces reviewed the tests and rejected the design, citing its slow movement, the frequent overheating of the electrical engines, and its inability to cover rugged terrain. A later version equipped with floats was designed and proposed for use against landing crafts, but this too was rejected. There is, however, one early remote control robot that stands out above all the others, the renowned Teletank. If during this video, you've considered that the Goliath might have been more effective had it been radio-controlled instead of cable-driven, then the Teletank proves you right. Impressively, the Soviets were experimenting with the Teletank as early as the 1930s, long before the Goliath was even conceived. Although much of the vital information about the Teletank has been lost to time, we do know that a series of experimental remote-controlled tanks were produced from the 1930s into the early 1940s. These tanks reportedly operated at distances of up to 1,500 meters. However, much like the Goliath, their effectiveness depended on the operator maintaining a clear line of sight. Several iterations were developed, but the Teletanks that saw combat were deployed during the 1940 Winter War when the Soviets invaded Finland. In this conflict, the Teletanks were outfitted with flamethrowers, smoke canisters, machine guns, and even deployable time bombs on occasion. The project was seen as having potential, yet the experiments ultimately failed for much the same reasons as the Goliath. The distant operator, stationed as far as a kilometer away, had to rely on a great deal of guesswork, which meant that the tanks proved ineffective when engaging enemy targets. Additionally, the teletanks were prone to losing signal, and a built-in failsafe would automatically shut down the engine if no signal was received for more than 30 seconds. Perhaps most fascinating is that at the time the teletank project was abandoned, a report indicated that designers were on the verge of installing remote television apparatus in the tanks, which would have allowed operators to see the battlefield remotely. Whether this advancement would have made a significant difference or propelled the Soviets ahead technologically remains up for debate. But either way, the teletank project was ultimately discontinued in the 1940s. Now, during World War II, remote-controlled military hardware was considered a failure, and the technology was left to languish as nations waited for advancements to catch up with their ambitions. It wasn't until the 1960s and 70s that real progress was made in this field, and today unmanned vehicles are more important than ever. Recent information indicates that the ongoing conflict in Ukraine is almost entirely dominated by unmanned aerial vehicles. Furthermore, the US recently claimed to have the largest drone fleet in the world, boasting 13,000 ready-to-deploy units. And as always, thank you for watching.